You are most welcome for this session. Today we are going to look at integration of exponential functions, and my name is Kaziba Steven. So we are going to look at how do we integrate when we meet an exponential. When you integrate it, what do you obtain? So that is what we are going to be looking at in this session. So whenever you meet an exponential function in terms of x or in terms of any variable, and we are integrating it with respect to x, we shall always get the same thing, exponential of x plus a constant. So exponential function, when you integrate it, you get the same thing. But what is the general rule that will govern us? Take an example. If we have an exponential of power ax plus b, and this is with respect to x, and we want to integrate it. So we are going to use the change of variables in order for us to integrate it. So we can say that let our u equals to ax plus b. So we know very well that when we differentiate on both sides, we shall have du is equal to a dx. Because b is a constant, you get what? You get a 0. So meaning that our du is the same as a dx. But since I'm interested in getting the x such that I can change the variables, I'll divide this side by my a. I divide this side by my a. So meaning that my du out of a will equal to dx. So where there is the x, I'll put du out of a. So meaning that I'll have an integral of a, but we have said our x plus b is the same as u, then times our dx, which is the u out of a. So since a is a constant, I can factor it out and I remain with eu du. So when you look at eu du, it actually resembles our general rule that whenever I have ex dx, I'll have ex. So here meaning that eu du is the same as having 1 out of a eu then plus a constant. But we have said that our u is the same as ax plus b. So I'll have 1 out of a into e of ax plus b, then plus our constant. And therefore, our general rule is going to tell us that whenever I have an exponential, ax plus b, or any power with respect to the x, this one I will always have 1 out of a into e ax plus b, then plus a constant. So what does it mean? That always look at what you have as your power. What you have as your power, differentiate it. But after differentiating it, divide what you have obtained after differentiation down and then write the original function. So in other words, always I'll have 1 out of the differentiated part of my function. Then after I write back my original function if of x, then I say plus a constant. So always I look at the function I have in my numerator, but as my power, I differentiate it. I say 1 out of that function. And then after, I write my original function. Take an example. Allow me to take you through step-by-step approach of how we can integrate. Take an example. I have e of 5x, then this is the x. So I can first say that let my u equals to 5x. So what does it mean? It means that our du is equal to 5 dx. Since I'm interested in the x, I'll divide by 5, divide by 5. So 1 out of 5 du will equal to my dx. So when I come back here, where there is dx, I'll put 1 out of 5 du. Then I'll have my integral of e power 5x, which is now u, then times our du out of 5. So this will give us 1 out of 5 integral of eu du. But we know from our rule that eu du, when you integrate it, you still get eu plus a constant. So here we shall obtain 1 out of 5 eu, then plus a constant. But our u is 5x. So I'll end up with 1 out of 5 e 5x, then plus a constant. Alternatively, you can use the other approach, whereby when I have integral of e 5x dx, what does it mean? I'm going to get my power. What I have as my power, I differentiate it. So when you differentiate 5x, you get 5. So I'll say 1 out of 5 Then I write back my original function. Then I say plus a constant. Okay, another number we can try out. Imagine we have an integral of e, then 4x plus 5. And this is the x. So I'm going to use the change of variables. So we shall say that let my u equals to 4x plus 5. So what does it mean? It means that my du is equal to 4dx. Since my 5 is, when I differentiate 5, I'll get a 0. So I'll have 4dx. So what will I have? My dx is the same as 1 out of 4 du. So I substitute back, I'll say e, whereby 4x plus 5 is u, then times the x, which is 1 out of 4 du. So this will give me 1 out of 4 integral of eu du. So your task always is to ensure that in what you have within your integral sign is e power something with respect to that variable. So here I'll get a quarter eu plus a constant, but I know my eu, my u is the same as 4x plus 5. So I'll end up with 1/4 e of 4x plus 5, then plus a constant. So that is your answer to the integral. Okay, we can try another number. Number 3, we can have an integral of 2e of 8x minus 3 dx. So for this one, I can first pull out my 2 and I write it as 2 integral of e 8x minus 3 dx. Then I can let my variable and say that let my u equals to 8x minus 3. So I'll have du equals to 8 dx. So meaning that our dx will be du out of 8. So I substitute back, I'll have my 2 integral of my e, but this is u times the x, which is the u out of 8. So this will give us 2 out of 8 integral of eu, then du. So when I reduce here, I'll have 1 out of 4 integral of eu du. But integral of eu du is the same as that same integral. So it's the same as eu, then plus constant. But what is our u? Our u, we let it as 8x minus 3. So I'll have 1 out of 4 e of 8x minus 3, then plus constant. Hope we are on the same page. I can have another one, an integral, then everything dx. Now, when you are dealing with such a number, the first thing you have to do is open up your brackets. So when we into 2 plus e 3x. So when the 5 enters, it affects everything. The same with ex. So I'll have 5 times 2 ex plus the 5 ex, then e 3x. So 5 times 2 get 10 ex, then plus e power x, e 3x. These are like having bases. Because the bases are the same, so what we do, we always add the power. So I'll have e5 e power 4x. So afterwards, I get this, I substitute it back in my initial thing. So this is going to be 10ex, then plus 5e4x, then everything with respect to the x. Now, if you want at this step, feel free to divide your integral. So you can divide and say, this is 10ex plus integral of 5e4x dx, and also this with respect to the x. So when you integrate this, you'll have 10ex plus, when you integrate this, we shall have 5. We have said we always integrate what we have, we differentiate what we have for our power 4x. So when you differentiate, then divide it out of 4, then write the original thing. Then afterwards, we shall go on and add a constant. If you want to simplify further, you are noticing that ex and ex are common. I can pull it out and I can pull out 5 out of 4. So when I say 5 out of 4 ex, it means that since here was 10 and this is 4, it means that it will go into it inside. So meaning that inside here, I'm going to come and I have this one will remain e3x. Because I've taken out 1x, then plus, here I'll have my 8, then I say plus c. So the moment you open, you'll get the same thing. Okay, we can try out one more number. This number, they can tell you that find the exact area, of the shaded region. So take an example. You have this is our graph, and this graph goes like this, whereby the whole of this part is the region that they want. So here we have 0, here we have 3, and the nature of this graph is given by 2e a half x minus 2x plus 3. So what am I going to say? So we know that the exact area under the shaded region is the same as having the integration. So we are going to, our curve is y is equal to 2e a half x minus 2x plus 3. So our area under the curve is the same as having the integral. But our x values range from 0 to 3. So we shall say from 0 to 3 of 2e power half x minus 2x plus 3. And here we shall say with respect to the x, since we are considering the x-axis. So, but this is the y-axis. So when we are going to differentiate, we are going to go on and differentiate each part. So I'm going to have my integral of 2e a half x, then minus 2x plus 3. So when we are differentiating, integrating with respect to x, I can come back and I first do this as outside. So when remember, I differentiate this. So when I differentiate, I'll say 1 out of a half. Then after I write the original thing. So 1 out of a half is the same as 2e half x. So meaning that when I integrate, this is what I'm going to get. But since there is a 2, I'll write it now as 4e a half x minus 2x. When I integrate, I'll have 2x, which is the same as 2x squared out of 2. The 2 will cancel, so I remain with x squared. So here, I'll remain with x squared, then plus the 3x. Then our limits are going to range from 0 to 3. So we can first put our upper limit. So when we put our upper limit, we shall have 4e, then a half times the 3 minus the 3 squared plus the 3 times the 3, everything minus the lower limit, which will be 4e a half times 0 minus 0 squared plus 3 times 0. So here we shall end up with 4e power 3 out of 2 minus 9. This is plus 9 minus, this is going to be 4. E to power half times 0. This is the same as e power 0, which is the same as 1. So we shall say minus 4, then the rest will be 0. So here negative 9 plus 9, we get 0. So we shall have 4e, 3 out of 2 minus 4. And this is our area, since they told us the exact area. So we shall not go on and find what is E3 out of 2. So this will be our area, and we can just say square units. So that is where you stop for that particular part. Okay, let me hope it is okay. So these are numbers that I want you to try out and see whether you have mastered how to integrate exponential function. But maybe for number 4, when they tell you that a curve is such that given the curve passes through point 0, find the equation of the curve. So still here, we are going to apply our integration. So we shall say our dy dx is equal to 6e 2x plus 2 exponential of negative x. So when we multiply times dx on both sides, we shall end up with our dy equaling to 6e 2x plus 2 exponential negative x, everything with respect to dx. So what are we going to do? We are going to integrate. So I can integrate. So when I integrate, I remain with y is equal to, now we have said when we are integrating an exponential, we always differentiate the power. 2x, when you differentiate it, you end up with 2. Then after you divide, so I'll have 6 out of 2, the original thing, plus when I differentiate negative x, I'll get negative 1. So I divide, I'll have 2 out of negative 1, e of negative x. Then after that, I'm going to add my constant. So this will give us y is equal to by 2, 1 by 2, 3. So we shall have 3 e to x. 2 divided by negative 1 is negative 2 e negative 6 plus c. But they told us that this curve will pass through 0, 2. So they have given us a point where the curve is going to pass. So this is your x, this is y. So our y is 2, we substitute. So I have 3e, 2 times 0 minus 2e power negative 0 plus c. This will give us 2 is equal to 3. E power 0 is 1 minus 2, because e power negative 0, 0 is a neutral number. So it cannot be negative. So it is in between. So you still remain with 2. So when you have e negative 0, this is the same as e0, which is the same as a 1. So 3 minus 2, we shall end up with a 1 plus c. So when we take the 1 this side, we have 2 minus 1 is equal to c. And therefore c is equal to 1. Now, after obtaining your constant, you go back to the equation and you fill in. So we shall have y is equal to 3e 2x minus 2e negative x, then plus 1. So that is what you call the equation of the curve. So that is how you obtain it. So try out the rest of the numbers to test whether you have understood the concept on how we integrate exponential functions. Thank you so much. Have a lovely day.